Hello everyone, today we are going to discuss classical mechanics. Classical mechanics is a fundamental branch of physics that deals with the motion of objects and the force acting upon them. It forms the basics for much of physics and engineering and is often the first area of study for students of the subject. Here are some key concepts and area of study with classical mechanics. Newton's law of motion. First law: an object at rest remains at rest, and an object in motion remains in motion at a constant velocity unless acted upon by a net external force. Second law: F equals to ma. The acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Third law: action reaction. For every action, there is an equal and opposite reaction. Kinematics: the study of motion without considering the force involved. Key concepts include displacement, the change in position of an object. The rate of change of displacement can be average or instantaneous. Acceleration: the rate of change of velocity. Dynamics focus on the forces that cause motion. Topics include net force, the vector sum of all forces acting on object friction, the resistance that one surface or object encounters when moving over another, which can be static or kinetic. Work and energy: the product of force applied to an object and resistance over which is applied. W can say F into W. Kinetic energy: the energy of an object due to its motion, given by Ke 1 to mv square. Potential energy: the energy stored in an object due to its position upon gravitational potential energy, given by P equals to mgh. Conservation energy of energy in a closed system to the total energy remains constant. Energy can be transformed from one form to another but cannot be created or destroyed. Momentum: linear momentum, the product of an object mass and its velocity p equals to mv. Conservation of momentum in an isolated system, the total momentum remains constant before and after collision. Rotational motion, the study of object rotating about an axis. A key concept included angular displacement, velocity, and acceleration, analogous to linear motion, but in a rotational constant. Torque, a measure of the force causing an object to rotate. T equals to Rx. Moment of inertia, the rotational equivalent of mass, or representing how mass is distributed relative to the axis of rotation or gravitation. Newton's law of universal gravitation: every point mass attracts every other point mass with a force that is proportional to the product of their mass and inversely proportional to the square of the distance between them. Application include orbits of planets, satellites, and understanding tides, oscillation, and waves. Study of periodic motion and wave phenomena. Simple harmonic motion, a type of oscillation where the restoring force is proportional to the displacement of a mass on spring. Wave transfer of energy through oscillation described by wave properties such as wavelength, frequency, and speed. Classical mechanics serves as a foundation for the understanding more complex physical phenomena and theories such as thermodynamics, electromagnetism, and quantum mechanics. If you have specific questions or areas of classical mechanics you would like to explore further, feel free to ask me. I will be here to. मिलते हैं अगले वीडियो